All right, so yeah, we can get started here. I see that people are starting to join. So yeah, once again, thank you, Jennifer. Thanks so much for being here with us. Just to introduce you a bit and to set the stage, we're going to be looking at a Canadian case study of an industry that is doing digital twinning today and doing VR and AR and all these exciting initiatives. Our keynote is by Jennifer Busler. She's the innovation manager at Seaspan, one of our sponsors today as well. Seaspan is an industry leader in terms of in shipbuilding in Canada, but also in terms of other major civilian and military naval projects. Jennifer, thanks so much for joining us today.
Thanks for having me and for the opportunity to speak to what we're doing at Seaspan around how we're integrating digital twin and AR/VR technologies into what we're calling digital ships, which is certainly an instance of shipbuilding in transformation. So first, I'd like to start off with a quick update on what is Seaspan Shipyards. So next slide. So Seaspan Shipyards is been around for almost 100 years. And we're one of the largest shipbuilding and repair companies on Canada's West Coast. And we have really 3 facilities. 2 of them are located in North Vancouver, and they include our Vancouver shipyard, where we're doing the majority of our National Shipbuilding Strategy new build work, as well as the Vancouver Dry Dock, which is a large facility that deals with the large and complex ship repair solutions. And then over on Vancouver Island, we have the Victoria Shipyards, which is also our center of excellence around ship repair and conversion. So we've done a variety of investments to both facilities and people that have allowed us to grow and become one of the most modern new construction shipyards in North America. In particular, through our 3 shipyards, we offer a full life cycle to owners and operators from concept design through construction, launch, commissioning, tests and trials, upgrades, maintenance, repair, and then vessel life cycle extensions. Next slide. Under Canada's National Shipbuilding Strategy umbrella agreement, Seaspan is working with the Canadian Coast Guard and the Royal Canadian Navy to build 5 classes of vessels as part of their fleet renewal programs. The scale and complexity of these build programs has led Seaspan to explore pathways that drive efficiency in design and build and ultimately delivery of modern vessels that are ready to have a long period of service and deliver on the missions that Canadian Coast Guard and the Navy are looking for. Next slide. So all ships, integrating a 3D information and digital information isn't new to shipbuilding. All new ships are designed in 3D. They do layouts and planning and concept designs. And this ultimately forms, if you want to say, the foundation, or it forms the basis of what we're calling a digital ship. So as we heard from Wolfgang, there's lots of different ways in which you can define what a digital twin is. But in our case, we're really putting together that a digital ship must have multiple attributes. It should have a physical, should be a representation of the physical asset itself, represented into the digital model. It should have a look and feel that's like the real asset itself. Ideally, it also incorporates visualization technologies and ways to interact with the design information, with the operational information in a way that makes it accessible and usable by different peoples at different skill levels. It simulates real behavior with varying degrees of fidelity. It includes relational interactions between systems. These are very complex system integration programs. And so we need to understand how things work together and not simply the act of overlaying data into a single piece of equipment or instrument. And then it also should be mirroring reality. And that involves connecting, you want to say, that 3D or spatial information into relevant data feeds that allows you to take those data feed information and potentially any analytics from it and place that within the context of that 3D environment or that physical environment in a virtual environment. Next slide. Within Seaspan, we've been building out a digital ship system architecture to help both with our new builds as well as with some of our in-service support solutions that we offer through our full three range of facilities. So it starts with a data asset platform, looking at bringing in the 3D models and other vessel data that's associated with the actual design, whether it's as designed, as built, or as maintained. It's also integrating in situ monitoring. So that's our IoT solutions and instruments that are placed into the vessel or are actually part of systems that are integrated into the vessel at time of build. And so this then goes into a data management system. And this does all that heavy lifting around data configuration, processing and storing that information, curating that information, making it accessible, formatting it, making it available into analytics platforms, where you're actually doing various data analysis that supports operational monitoring, doing issue detection with individual systems or subsystems, planning or decision support at the vessel level or at the department level for in-service support. And then this integrates with a 3D visualization platform where you start bringing it all together. So it's that contextual placement of information into a 3D representation. Then that flows into and use of an immersive visualization facility. So that facilitates these shared and collaborative solutions that use augmented reality as well as virtual reality in order to access and best utilize some of that information that's then contained within this digital representation. Next slide. So we're calling our state-of-the-art immersive visualization system that we've just installed at Seaspan at our North Vancouver facility, HoloShip. And it really facilitates collaboration with an immersive solution that's then portable. So the three major components of it include a large display wall that allows 3D visualization with full motion tracking and 3D stereo imaging for up to 20 people. And it's then compatible with all the different CAD software and various other solutions that can come in and integrate into a 3D immersive environment. That's then combined with a set of VR goggles that allows a person to actually have an in situ experience with the 3D information and enables multi-user visualization sessions as well. So you can use them in combination. You can have one person that's inside the VR system and then a series of people that are interacting with that person and understanding and seeing what they're seeing within the large 3D imaging space as well. Then this VR system is also portable, so it can go out into the yard, or it could go to a customer side or to a collaborator, and you can start facilitating use of the visual information and the 3D information across the whole team, whether they're all in one place or they're distributed across different facilities or locations in Canada. Next slide. So the use of artificial reality and VR technologies substantially enhances digital shipbuilding. So stakeholders are able to engage with the information in sort of new and novel ways or ways that make it more accessible to them. And this goes everything from concept design to placing those 3D analytics and visualizations into the actual spatial context that they're in. In particular, it's very useful for customer engagement or non-expert engagement and trying to work through some of the complex decision-making that happens in the shipbuilding process. For engineering teams, it allows items like human factors to be integrated early and throughout the whole design process. It facilitates detailed to functional design decisions, comes up with ways in which we can do build strategies around complex portions of the vessel. And in particular, it helps with the whole change management process, being able to keep things digital longer. For lifecycle operations, use of these visualization technologies allows us to, again, take equipment performance and put it into a concept of the actual spatial scale. It allows the integration of performance with the spatial environment to then support in-service support, maintenance and management and planning. And then also it can facilitate the whole vessel handover process and training associated with using that vessel or the systems and maintaining those systems on the vessel. In the 4 months that we've had this particular facility up and running and starting to get people familiarized with it and using it, I can honestly say that people engage with the 3D information and the digital information very differently when working in an augmented or immersive environment. It makes the information sort of inherently accessible, and therefore they get the actual full impact of adopting a digital path over the physical path that they might be more familiar with. And that just really realizes those efforts that you're putting into creating this sort of chain of digital information as it goes through the build process. So it basically makes information placed into a physical, if not virtual, context. And it helps to reveal, if you want to say, hidden information or things that they might have missed if they had to look at it in just in 2D plus or paper, or trying to come up with other visualization solutions. So it makes complex information easier to consume and understand. Next slide. Oh, we're one slide ahead. So we're going to go to the next slide. Digital shipbuilding. So digital twins and AR technologies really do become part of the digital shipbuilding process because it has these impacts on new builds all the way through design integration with earlier and frequent use of 3D information throughout the design lifecycle. It introduces production process improvements. So changes that are made while everything's still digital are both easier and less expensive. And integration of safety and human factors at critical stages in the design and build. And then this transfers into operations. When you start combining the digital twin with real-time sensors or IoT, this leads to performance-based operations with it, which extends into automation of systems or subsystems. And then that puts even large, really complex vessels like we're building under NSS onto a path for autonomy, or to centralize support for remote operations and various other solutions that we can look at going forward, because we have this representation of that vessel into a format that can then potentially be shared or distributed. Using digital twins can also better coordinate times and work order planning for more efficient dock periods and maintenance and repair. Moreover, the opportunity to move from preventative maintenance into conditional or ultimately predictive maintenance becomes accessible once you start having that flow of information and that ability to sort of start tying those simulations and virtual solutions with real-time data. Then all of this has a substantial impact on reducing the long-term in-service support costs over the lifetime of the vessel. Now, underpinning all of that is the complexity and challenges around how do you create this continuous integrated sustainment of the asset data and the models and all these different representations across these major phases of a vessel's life cycle. So next slide. So to fully realize the potential of digital twins and visualization technologies, they really do need to be adopted and built and then used meaningfully across the whole supply chain. So it's not just a matter of, a prime like Seaspan coming in and saying, we shall do it this way. It really is about how do we get the whole ecosystem to start using and integrating it, because they flow up into these large complex systems. So we really need to have it across the whole industry. And we're all at different phases of this digital journey. We all have different agilities and priorities and resources available to us. And so there isn't really a single right answer. And the journey isn't really going to be linear either. It's not as simple as just putting it into requirement and therefore it shall happen. It really is about, how do we do this sort of collectively as an industry? Next slide. So when we think about the challenges and opportunities associated with adopting digital technologies, we often immediately jump to those technology gaps. What are the information management solutions that we need to put in place, and how do we, deliver the data granularity that's needed for each particular use case, and manage the variable complexities across, the models and the information that's coming in, and the data flows and rates, and the data continuity that might be associated with that, and format standards and network capacity to be able to take on all these IoTs and funnel it through satellite comm systems. And so there's all of these really interesting technology areas that we can address. But the adoption of the technology isn't just about the technology. You need to have business solutions that really help support this evolutionary process that we're all under. And some of our our default waterfall procurements where we set out requirements and deliverables, sometimes decades ahead of when you actually build them, deliver them, and then operate that system. How do we then integrate the changes that are needed to evolve into this more digitally enabled solution going forward? How do our fleet management strategies impact how data flows from builder to operator to maintainer? And so there's just lots of different ways in which just how we conduct our business potentially needs to be evaluated on how do we stay nimble and adaptive to integrating the technologies and the potential that they offer to improving our business overall. And then there's capacity around being able to use these solutions, knowledge, utility. Adoption is really about familiarity, and are the tools sufficiently mature? Do they deliver on what expectations are for that? Do they really deliver on an improvement to the efficiency? How do we improve utilization of those tools? So we start then looking at, what are the skills and workforce development that we need to build up and have the right skills available for our design teams, for our operations teams, for our maintenance teams. Or do we have the facilities and the process integration in order to make sure that as those tools come online and become available, that they're adopted and used and really put into place? How do we use investments and partnerships and ecosystem development in order to address the ongoing evolution of technology and close some of those technology gaps that are here today, but might not be there in 5 years or 10 years from now? And then how do we look at collaborations and potentially other industries that are a little bit further along their digital transformation process, and how do we bring in some of those crossovers and how they've integrated into contracting or into management strategies that allow them to sort of have that continuous improvement going forward and use of those digital technologies as they evolve. So lots of challenges and opportunities. And so we also need to really avoid boiling the ocean, so to speak, right? We need to just sort of sit back and collectively recognize and then seize upon the potential that these emerging digital twins and visualization technologies really offer into the marine industry, and consistently and intentionally work them into an evolution of both the technical and business processes at all levels. So from subcontractor to supplier to prime. So under the National Shipbuilding Strategy, Canada is on a journey to revitalize and rebuild our shipbuilding and marine industry. So at Seaspan, we see this as an opportunity and a unique and exciting one for the rapid evolution needed to meet these challenges and be competitive globally. So thanks everyone, and last slide.
Yeah, thanks so much, Jennifer. Yeah, it's a great shot there too. Yeah, the cave is certainly an exciting initiative, and because it's so right in your face and it's accessible to everyone. Yeah, thanks so much for that look at what's going on at Seaspan. We do have quite a few questions here, so we have a good amount of time to get through them, so we'll get started. The first question here is from Jacqueline. She asked, what software do you rely on for data integration? I know that's was a key point in your message.
So some of our integration is through how it's being supplied, and some of it's sort of custom built in terms of some of the data integration. But we are, utilizing existing software in the industry for like as integrator. We're using all the different CAD tools, whether it's through CADmatic or what's offered as SSI. Those are really where, if you want to say, the source of all that information comes in, and then that's being put into databases and other management strategies, then try to collectively put that together with tools and scripts to be able to build that out and make it accessible into those different sources in the analytics. So it's not a single one source answer. It's not one platform. Yeah,
and one thing I was thinking of is that, as well as anyone, that shipbuilding is quite a unique industry, and it's different from a lot of other manufacturing industries. How does that influence what decisions you make in terms of pursuing these innovations? How do you have to tailor things to shipbuilding in a certain way?
So yes, because there isn't any there aren't ready-built solutions that are out there. I think the digital technology adoption is emerging into the marine industry and into shipbuilding. So it's a process of evolution. Yeah, there are adaptations that need to happen, but there's many things that are similar, or they're definitely sufficiently parallel or comparable that you can transfer them over. And then the complexity at Seaspan of having 600 plus suppliers in our supply chain. There are many stakeholders that come in and they bring in their expertise. And so you need to have that sort of collaborative environment when you're integrating systems at that level. So.
We have another question here from Dimitri. Who do you see as the owner of the digital twin? Is it the designer, the shipyard, the operator, the owner? Yeah, what from your perspective, how do you see it?
I don't know that that's a hard one, right? Because ultimately the digital twin is probably tied to the asset, right? That's the most meaningful connection. So the owner of the asset probably should own the digital twin. However, it needs to be accessible to everyone that supports the owner of that asset, whether the operator of the asset, the builder of that asset, the maintainer of that asset. And so it needs to be available to all the different participants, but it is tied to that particular asset. It wouldn't make sense for it to float off literally on its own, right? And then be disconnected from the digital twin because it's owned by the shipbuilder. And then it becomes unavailable, right? So it is one of those things where it's probably tied to the asset at best, and then it should be made accessible to the people that are working with the owner to operate and maintain and build.
Kind of on a similar line, how do you maintain the integrity of the digital twin throughout the life cycle? So from the design stage all the way to commissioning, there's so many changes happening. What are some things that Seaspan's doing to kind of, how are you thinking about that?
So we're using shared workspaces is one of those ways in which to do that. So a lot of configuration management is also around that, trying to track through processes, various ownership of pieces. I think a lot of it comes down to consistency within the process of building out that digital twin or building out that particular model. These aren't new problems. They existed when we were just doing 3D models. So we're really just, taking much of those experiences and then expanding them out to how do we then potentially integrate other sources of information and changes along the way. So these aren't new problems, and they're consistently hard problems to solve, but they are solvable.
One of the things you mentioned is also the idea of collaboration, and obviously that's a huge part of the value of VR and AR and these types of tools. Has COVID accelerated that? Has it brought it more into light?
Oh, what is it? Necessity is the motherhood of invention. So I'll have to say that, we had planned on installing our 3D AR environment much earlier than we did, and it was actually delayed due to COVID. So that aside, how does something like a distributed working environment improve? It does. It allows people to engage in a different way with the data, being able to have it distributed across that way, being able to have information that can be passed along digitally and then used between us and our partners in Newfoundland is critical. So certainly from that perspective, I think COVID has provided many early test cases for how we would use these in the distributed teams that we have already experienced within building the vessel systems.
We have another question from Jacqueline, and it's along the lines of, right now, climate change is at the forefront of so many of our discussions. Is there a way that you can use these digital tools and innovations to help you implement green technologies or renewable energy in some way?
That's a great question. So yes, one of the other interesting things about digital technologies is it's a innovation strategy all of its own, but it's an innovation strategy that brings together all sorts of other technical innovations. And so yes, a digital twin does allow you to either explore the what if scenarios for midlife upgrades or changes or refits that you might want to do on a vessel very early on in the design process. So you can start, I don't want to say future-proofing, but you can start at least de-risking or having some idea as to whether or not if you were to swap out an engine or go to a different propulsion system, or think about how you would redo a system later in the life of the vessel, you can start doing that earlier, right? You don't have to wait until later. The other part of it is with the whole use of IoT and sensors, you can start coming up with much higher fidelity estimations that might be associated with emissions monitoring, power consumption, power use along the vessel, and then that all kind of integrates into the digital environment, and then you can start running models that help, you know, come up with much more accurate emissions estimations, rather than so many, you know, gallons of fuel were burned, therefore it's, you know, it's created so many emissions. So it allows a much more sophisticated approach to be used in the solution, both in future-proofing vessels, redesigning for new vessels, and then also in being able to better operate the vessels that are in operation today.
Yeah, fortunately, we have the problem of too many questions, so we only have time for a couple more here. This one's from Charles. He asks, can you access the distributed learning aspect through any platform, for example, a phone, a tablet, desktop?
So Seaspan itself does not build the learning platforms themselves. We work with our suppliers to do that. So that would be done in partnership. So the short answer is it sort of depends on the capabilities of who's building out those training sessions themselves. From the builder's perspective, is we want to make sure that some of that information has that reuse, and that there is, if you want to say, this continuous process between how they take some of the as-built information, convert that into training information, how the impact of that training information potentially comes in and then influences the design. So you end up having this nice cycle of exchange rather than just, you know, one particular person delivering that in. So that, again, back to that idea that it's really about the community leveraging this digital resource and making sure that that information is shareable. I don't know, we have to work on shared, right? But it's shareable.
Yeah, thank you so much, Jennifer. I'm afraid that's all the time we have for today. It was really insightful listening into your presentation and getting a look at what's going on at Seaspan. And yeah, thank you so much for the audience. There's a lot of questions. Yeah, and we'll have to have another session sometime soon to get to all of them. Yeah, thanks a lot. And I invite everyone to join us in the next panel. It's their innovation panel. Just hop into the next session. We have a lot of great Canadian SMEs and government groups talking about what we're doing in Canada. Thanks a lot.